Yeah. Kashyap is here, it seems.
Yeah. Hello. Hi.
Okay, thank you.
Hi, Arnab. Can you hear me?
Yeah, I can hear you.
Yeah. So we'll start the session in 1 minute, and I will just introduce you to the attendees, and then you can take over.
So how do I share my screen?
So I'll just stop sharing, and once I stop sharing, then you can share your screen using the green button on the tab.
Okay.
Yeah.
So this is Zoom running, or
Yeah. Can you see my screen and your banner on it?
Yes, I can see the banner and I can see you. Yeah.
Okay. Awesome. We'll just wait for a minute and then we'll start.
Okay.
Okay. Okay. Welcome back, everyone. Before we start the next session, I would quickly like to thank our sponsors again, our presenting partner, Great Learning, Platinum sponsor in Sophie and Praxis Business School, and our community partner, the Association of Data Scientists. Moving right along to the next session, our next speaker is Arnab Laha, Associate Professor at IIM Ahmedabad. Professor Laha takes a keen interest in how AI ML or data science can be used to solve complex problems of business and society. His areas of research include advanced data analytics, quality management, and risk modeling. He has published more than 25 papers in peer-reviewed national and international journals of repute and has been named as one of the 20 most prominent analytics and data science academicians in India by Analytics India magazine. Today, Professor Laha will be speaking with us on how to get ready for a career in analytics and data science. While it is one of the most attractive career options, there are a lot of factors that one needs to consider before starting out in this field. So Professor Laha will be taking us through the various techniques and domain knowledge that is essential to make a career in data science. He will give us some tips on how to learn, unlearn, and relearn, which is an essential paradigm if one is to have a successful career in this field. Uh, before we the session will be the session will end with a quick 5 minutes Q&A talk. Professor Laha, you can take the questions in the last 5 minutes. Attendees, you can post your questions in the Q&A tab or the chat box. The screen is all yours, Professor Laha.
So let me just share the screen.
Yes.
Is my screen visible?
Yes, and it's in full screen mode as well.
So thank you and Analytics India magazine for welcoming me to give this talk on a topic which I've been dealing with for quite some time now. And I receive a lot of queries from youngsters asking specific information about this, that what careers are sort of attractive when you are sort of thinking in terms of a career choice, particularly post 10+2 or after graduation. And one of the career options that do come up very regularly nowadays is a career in analytics and data science. Now, the purpose of this talk is to sort of tell you what is generally a professional in this field does and what things need to be done if you want a successful career in this space. So I begin by sort of outlining what is analytics and why analytics is important. Now, analytics is a omnibus term which has seen more and more usage over the last 25 years. And what it has done is that it has actually improved decision making. So what analytics generally does in whatever field it is used is that it aids decision making. Now, when we say decision making, the term is often not very clear what we really mean by by sort of telling that we are making a decision. So when we say that we are making a decision, we are basically thinking in terms of multiple available alternatives, of which we are choosing one based on a lot of information that we have. Now, this information may be qualitative information, or it may be quantitative information, and it may either involve a huge amount of data or very little amount of data. So actually, based on the alternatives that you are having and the domain context, these things and the quantum of data that you will have may actually change. In some problems, it becomes extremely difficult to have even a very small amount of data. So that may be extremely expensive to get that kind of data. So what analytics does is that it provides a systematic way to choose the best course of action among the available alternatives. So you have many alternatives. You may have data, and you will sort of use the tools at your command to ensure that you are able to pick the best among the available alternatives. Now, there will be another aspect that if you're thinking of this carefully, that is of how do you get to the alternatives. Okay? So that itself is a science in science, and one does have various techniques to actually generate the alternatives. But we are assuming that we have these alternatives, and then analytics will help us in choosing the best course of action. Now, once we understand what analytics is, the next question naturally is that where can you use these analytical techniques? Now, this can be used in a variety of domains, and it has been used successfully in multiple domains. And the common domains where we see fantastic applications coming in are, of course, business management, where we see a whole plethora of tools that are available in this space. We see excellent applications that are being developed in the space of healthcare, and also we have very important applications that are being done in the engineering space. So business management, healthcare, and engineering are three major domains of application of the analytics techniques. However, there are many other domains which are catching up. Sports, particularly sports analytics, is again a big area that is coming up. Entertainment, which involve a whole gamut of things, from television shows to movies, to say things like radio programs. So a whole lot of entertainment medium is there, and analytics is playing a very important role in sort of telling us answers to important questions that are being generated in this field. Another field where we are seeing applications is that in the field of law. So law again is a very complex field, and analytics is trying to inform us about how we can better abide by the law, what would a possible judgment by a court look like based on the facts that are presented before it, and so on. Education, particularly personalized learning, online learning, are big arenas which have been impacted by COVID-19, and they're up for disruption using analytics. So what we are expecting to see in this space is that we will see more efforts towards personalizing the education delivery to the individual instead of the mass education delivery that is generally the norm. We are looking at interesting applications in politics, as we see political consultancies are coming up, which are trying to understand the mood of the electorate or the mood of the public with respect to various issues, and then informing decision making of the political leaders and the political parties. And there are many other applications that we can talk about. Now, one common question that is asked is that, is big data necessary for doing analytics? Now, so first of all, what is big data? So this is a term which is essentially a 21st century creation. So this term would not have existed even 15 years from earlier. So this term generally refers to a variety of things. So of which three are most often talked about. One is that these data sets are very huge. So we talk about terabytes and maybe a few tens of terabytes of data, so huge amount of data. So volume of these data sets are very large. And when data set volumes become very large, we can actually, or we need specialized way of handling those data sets. And that refers to the volume challenge with big data. We have another V, which is in the form of variety. Now, variety means that your data is of multiple types. So some of these data may be numeric, some may actually be categorical, some may be in the form of images, some may be in the form of text. So the data itself is not of one kind, but consists of multiple kinds. Say a Facebook post is a data which has several things, like you will have possibly a text, maybe an image, you will have some sort of reactions to it, like the likes and dislikes. You may even have some people giving emojis. So all of that are data associated with this Facebook post, and all of this together would give us some understanding of the post. And the third facet, which is particularly interesting in today's world, is velocity. Velocity means that data is coming continuously and often rapidly. Now, what kind of applications generate this? Any application which involve a sensor. So say, for example, you may actually hear of things like Internet of Things. Now, in Internet of Things, you have quite a few sensors put on machines, like a tractor or an automobile or a CT scanner or some robotic surgery equipment. Now, these sensors would continuously give information about the health of the machine. So is this structure going to go down? Is some parts of the structure malfunctioning? All these kind of information can be figured out from the information that are being sent by the sensors on these devices. Now, the characteristic of these data is that it continues to arrive. So there is nothing like a finite limit. It's a potentially infinite. As long as the machine runs, you will have sensor readings coming in, and one has to deal with it. Another kind of place where high velocity data is generated is, of course, video and audio streams, like say on a television network or in a YouTube channel, or even the Zoom meetings that we are having. So there again, the information is being fed at a very high rate, and one can do some analytics based on that, based on these data. So a big data is generally considered to have these three attributes, but let me tell you before you get confused that not all data sets may have all the three attributes. So Some data set may be very large, but maybe only numeric. Some data sets may be smaller, but may have multiple attributes for each data element. And some data may be of just one quantity, but it may be the data is maybe rapidly evolving over time, and that would have the velocity. So it's not necessary that each data set will have these three, but when you talk about big data, these are the three critical V's that we talk about. Apart from that, there are many other V's that have been talked about, like veracity, value, and so on, but I don't think that is very important with respect to today's discussion. So when we talk about big data, one of the fundamental questions is that, is it necessary to do good analytics, we need big data? The answer is sort of nuanced. So there are many exciting applications, say chatbots, things like CD or this Google Assistant or Alexa. Now these kind of applications are very sophisticated artificial intelligence applications, and they indeed need very large data sets for producing these kind of good models. So in some applications, in natural language processing or image processing or audio signal processing, we indeed need a fair amount of data to be able to build good models. Now, the reason is that most of this data is unstructured, and therefore, without a significantly large data set, it is very difficult to draw inferences with this kind of data. Now, however, there would be many areas, particularly in medicine, in some areas of engineering, where it is actually very difficult to get a large volume of data. So for example, if you are trying to develop a molecule for treating a rare disease, it may be extremely hard for you to get efficacy data, because the number of persons who are affected with this rare disease would itself be very small. So therefore, it is sometimes either scarce, or it might be available, but it may be extremely costly to acquire. So there, again, it will be very difficult to have a big data. Say, for example, if you are doing ammunition testing, now if you have to get big data, you will have to actually waste huge amount of ammunition, which may not be possible. So therefore, the data sets in these places would necessarily be of small data type. The good thing is that using the tools of data analytics, it is possible to build good models based on even small data sets, and that's where the data analytics skills come into play. Now, before I talk about careers, I would just talk about what kind of questions that you would like to answer. So one good part of being a data analytics specialist is that you would be able to answer questions which are of great importance to your own organization and also to other organizations. Okay, so say for example, also to the society. So therefore, there is a sense of satisfaction in solving these kind of problems. So I sort of list out a few questions here. So for example, if you're a telecom company, one of the critical questions that you may be trying to answer is that you have a particular customer, say for example myself, and one of the questions that you will be asked is that, is it likely that this customer is going to leave this organization and go to the competitor? Okay, so is this person going to attrite? Is this person going to churn? So, and if your answer is yes, and as we all know, the customer acquisition costs are generally much higher than customer retention cost, then the company may actually pay more attention to this customer and trying to retain this customer rather than allow the customer to go to the competitor. Another question now, say for example, a large diagnostic lab which is doing a large number of chest x-rays. One fundamental question is that, is this chest x-ray abnormal or is it normal? Now, if it is abnormal, of course, a radiologist will have to look at it carefully and outline the abnormalities so that proper treatment can be done. But if the chest X-ray is normal and without any abnormality, it can be sort of just the person may be told that your X-ray is normal and no further processing is required. So therefore, even if we have an algorithm which just says that the chest X-ray is normal, it is actually very helpful. And therefore, such questions are of great importance in image processing, where you are trying to sort of figure out a very simple thing, that whether a picture is normal or not, whether an image is normal. If you are a bank and you are giving loans, one fundamental question that a banker always faces is that, is this customer going to default? Is the customer going to run away with my money? Is this company going to become bankrupt? So customers' credit scores are generated. So which basically tells us how risky the customer is. So therefore, again, analytics helps in understanding that part. That is, it helps the banks to understand that whether a customer is inherently risky, is likely to result, a loan given to the customer is likely to result in a default. And if so, then they may not actually provide the loan. So therefore, again, these algorithms are very, data analytics plays a very important part in these kind of decision making. For a hospital, and we are seeing that due to COVID-19, a lot of hospitals are without beds. Even in normal times, one important question for a hospital is that how long will this patient stay in the hospital? You may know that actually hospitals don't want the patient to stay very long. In fact, we know that a large proportion, a significant proportion of the hospital's revenue from a patient actually can be obtained within a day or two. Okay, so within the first day or two, they get most of the revenue, which may involve a lot of diagnostic tests, surgery, or whatever procedure that is required. So the most of the revenue is collected within the first 1 or 2 days. And therefore, if the patient stays long in the hospital, it's not very good for the hospital, because if they are actually taking up the bed for other patients who may actually need the treatment. Now, having said that, another important aspect is that the hospital cannot release a person unless the person is safe to go home. If the person is released before, if the patient is released before he or she is safe to go home, one can actually create a risk of readmission, or some other complication may happen at home, which may not be easy to handle. So therefore, this is a very important question that hospitals need to answer. That how long will this patient stay in the hospital? I talked about IoT devices earlier, and one question that can be attempted to be answered using data streams generated from sensors is that, will this vehicle need emergency servicing? So if it needs emergency servicing, say within the next 3 months, one approach may be that you sort of you plan for the maintenance before the actual failure happens, so that the customer is not inconvenienced. So you figure out from the customer which is the day which is most convenient and service the vehicle without any need for the vehicle to go for a emergency repair and maintenance. In sports, and sports is becoming highly commercial, so in sports, you know that television audience brings in a lot of money. So one question of importance is that what would be the size of the television audience for a particular match, say a India-Australia T20 match. Similarly, in entertainment, estimates of box office collection of films involving certain stars, say here I have mentioned Tom Cruise and Scarlett Johansson, but any other stars, there are many Indian stars also which you can think of, and you can sort of try to figure out that what would be the box office collection, and that would help you in sort of figuring out that how much money you possibly need to put in promotions and other things, so that the film gets enough exposure and audience comes in. Now, whenever I give such a talk, one fundamental question that pops up is that, is analytics different from data science? Okay, so the answer is, well, Not entirely, but yes, there is a significant difference. So when we talk about analytics, we are basically talking about modeling of data using statistical and machine learning tools and techniques. Okay, so the focus is on modeling of data. Focus is on uncertainty quantification. Whereas when we deal with data science problems, the focus is more on efficient storage, retrieval, processing of data using primarily tools drawn from computer science or IT. Okay, so if you are dealing with data science, most of the tools will be tools that has its origins in computer science or information technology. Whereas when you are dealing with analytics, most of the tools will have its origin either in statistics or in machine learning. Now, the boundaries of the disciplines are not watertight, and there is significant overlap. So I'm not saying that if you're an analytics professional, you will not need to know any of the tools that I've listed in data science, and vice versa. So when we talk about careers, remember that we talk about this very casually, but a career is a long time. So you will be, say, if you are a young graduate now, maybe 22, 23, and you will retire by the age of 60. So it's a long time. So 30, 35, 37 years or more, with longevity increasing, you may be working even longer. So it's about 4 decades of work that you are talking about. So when we are thinking of such a long time horizon, what you need to do is the fundamental question. Now, why we should even consider a career in analytics and data science? The first is that this career would allow you at different time points in your life opportunities to contribute significantly to problems that impact organizational performance. So the problems that you solve will have impact on organizations directly. So it will possibly hit the bottom line directly. More immediately, this would give you a good pay package. Data science and analytics jobs generally have much better pay package than other kinds of jobs. So there is a promise of securing a good pay package. And if you do well, you possibly also have a reasonably fast career progression. And finally, and this is a part that not every employee gets, is that you would have an opportunity to interact with and even sometimes advise the top management of an organization on tactical and strategic decisions. Okay, so this is a very rare opportunity that is obtained in other disciplines, but this is quite common because of the nature of analytics and data science. It is quite common in this profession that at some point, maybe not at the very beginning, but maybe after a few years, you will have this opportunity to interact with the top management of organizations. Now, how do you prepare for such a career? So if you're trying to prepare for a career in analytics, my suggestion is that spend enough time and effort to develop a good knowledge in statistics and machine learning. This is essential. Okay? You cannot stay relevant in this field unless you develop a good knowledge, a foundation in this field of statistics and machine learning. You have to have a proficiency in programming and handling databases. And of course, I would repeat this multiple times, domain knowledge is essential. So you have to have a reasonable understanding of the domain. If it is business management, you will have to have a reasonable understanding of business. If it's in healthcare management, you will have to have a reasonable understanding of the healthcare domain. So if you're looking at the skills needed for a career in analytics, my suggestion is that you develop a good understanding of calculus, both univariate and multivariate, linear algebra, probability, statistical inference, and regression modeling. So these are the very basics. Now on it, you will develop further pillars of knowledge, but this is the bare minimum that we need to know. Right? You develop a proficiency in R and Python, and if you already know C or C++ or Java, it's all good, but at least these 2 languages you should have a good proficiency in. And I've already talked about the domain. When it comes to data science, my suggestion is that you develop a good knowledge of algorithm design, because most of this is going to be implemented using efficient algorithms. programming, database management, and cybersecurity. This is becoming more and more important as we are deploying these models through the internet. So cybersecurity is becoming a critical element of analytics. You must have a proficiency in basic statistics. Advanced statistics is desirable, but it's not really necessary for data sciences. But basic statistics you should know very well, and domain knowledge. Now here, if you look at what techniques you should master, I would suggest, of course, programming languages like Python, R, and JavaScript, algorithm design, handling databases using SQL and NoSQL, distributed databases like Hadoop, Spark, and its related technologies, and some cybersecurity tools. In statistics, definitely you need a good mastery of descriptive statistics and data visualization. These are very important because you will be dealing with very large volumes of data, and people will ask you to visualize the data for them so that they can take action. And of course, reasonable understanding of the. Now, as I had said, that this is a field which is rapidly evolving, and therefore a career of 35, 40 years is very hard to predict. So what are the tools that you will need to know? My guess is that because of the rapid progress in AI, the world will look very, very different in, say, 2060 than what we are seeing in 2020. If I sort of extrapolate from my own life for the last 4 decades, I can see that some of the things that I'm doing today was like science fiction 40 years back. So therefore that would be the kind of change. So it's very hard to predict. But what I can definitely say that many of the tools that you are now graduating with would be irrelevant in those times. So why? Because the nature of data is changing, and we are seeing more and more unstructured data that is coming into play. And the pace of change is fascinatingly fast to the point of being scary. So it's a very rapidly changing field, and new tools and techniques are coming in all the time. So they're being produced by industry, they're produced by academia. So the huge amount of tools and techniques are coming in, and one is expected to sort of at least have decent mastery of some of these as they go ahead in their career. So whatever you learn, you need to know very well, but you should also be prepared to unlearn some of the things, because obsolescence of knowledge rate is very high. So some of the things that you know very well may actually become obsolescence by the time you say you are in the job for 5 years. It might be that these are all irrelevant, and you need new tools. Now, to need new tools, and by the nature of these new tools, these will be based on the fundamentals. So where the fundamentals are right, you'll be able to catch it up. But you will have to have that learning attitude, that you'll have to continuously update your knowledge repeatedly along the over the years. So one has to be a lifelong learner, and periodic upgradation of knowledge base is required if you want to remain relevant in the profession and you want to build a career in analytics or data science. So with this, I will say thank you. So any questions or comments, I'll be happy to take.
I think we have 3 questions in the Q&A tab. So if you would like to take them up.
So I have already talked about the first one that Sweta says, that what are the different skills and how are they different?
Correct.
How much data do you need for the diagnostics? Now this I do not know what diagnostics are you talking about, but if you are talking about medical diagnostics, quite a bit of data is required. In fact, what you need is labeled data, and which is sort of very important, because say, for example, in a chest X-ray example, you need to feed the algorithm with instances where there is abnormality and with instances where there is no abnormality. And then only the solver would be able to figure out that what distinguishes these. Data engineering and data science life cycle. Data engineering is critical. Even it should actually be done even before you start collecting the data, because if you really do this part well, then a lot of complexity later down the analysis pipeline becomes easier. Okay, so I would say that the relevance is quite high, and people should spend more time on this particular area. And I think a data science professional will have to do a bit of data engineering as part of their jobs.
Okay. I think those were all the questions. If anybody else has any more questions, they can catch up with you in the lounge area. We are also having one-on-one mentoring sessions which are being carried out in the lounge area. So you can book your 15-minute power one-on-one session there. I think apart from that, we can wrap this up session. Professor Laha, is that okay?
Yeah.
Okay.
Thank you.
Yes. Thank you so much.